So previously we've seen how to simulate projectile motion using a spreadsheet. In this video we're going to use another method that I think you might find to be a little bit more fun and interactive. What we're going to do is go to scratch.mit.edu, and you'll be working from a template, but I'm going to build that template so you can see how it works. You'll need to make an account in order to save your work. But first, let's click on Create. I've created a new project here, and what we're going to begin with is something called a sprite. Here we have the default sprite named Scratch, this cat, which is the same as the name of the programming platform. We also have backdrops, so I can select any background I'd like for my projectile motion. Let's see. I think I will choose a hayfield, and maybe instead of the cat, I'd like a little more customization. I'm going to choose an apple. And let's get rid of the cat. I can just click on that trash can, and now I have just an apple. Over here on the left, we have these different colored dots, and each of them is a collection of commands that we can apply to that apple. Since I have the apple highlighted here, my commands apply to the apple. First, I need an event to begin my program, and when the flag is clicked, the program will begin. First, let's resize that apple. It looks a little bit artificially large, like a UFO floating up there. Let's set the size to 25%. Now when I click on the flag, I can see that my apple has resized. Next, I'd like to define some variables. This lets us control numbers. I'm going to click on Make a Variable. My first variable will be called X. And now I'm going to drag this to the right, set, I'll choose X to -140, and you'll see why I'm picking that number. I want to repeat this process to make some other variables. So we've created dt, g, vx, vy, x, and y. I don't need this my variable variable. I'm going to right-click it and click delete my variable, just to keep things a little bit more tidy looking. Next I want to set y, and I will say -80. And then to see what we can do with this, I'm going to go here to Motion, the first blue circle, and choose Go To, then come back to my variables, and I will choose X, Y. So I've defined X and Y, and now I'm going to tell the apple to go there by clicking on the green flag. And we see that the apple goes to somewhere in the hayfield, where we can begin a launch. You may remember that we need some time step because we can only do this simulation in discrete steps. Unlike actual motion, this happens in a step-by-step way where we update the position. I'm going to set my dt equal to 0.1 seconds. Just like our previous simulation, I'm going to set vx equal to 30, vy equal to 40. Let's set g equal to -10 meters per second squared, of course. And now we need some control to have our program continue for some amount of time. Let's use a repeat until structure here, and you can see this looks like a mouth that I can feed something into. I need a condition to stop the program so it doesn't run forever. I'm going to click in the green Operators tab and choose a greater than sign. I think I will repeat. I see that my apple is currently at -140. Let's repeat this motion until the apple is located at +140. So I'm going to click on my variables here and drag X into that empty oval. Now we need to change something. We're going to change X by some amount to move the apple to the right. I'll use operators to accomplish that. I know I want to multiply two things. I want to multiply how fast I'm going by how long I've been going that fast. So here, how fast I'm going to the right is Vx. And this is tricky. I see the outer green circle is highlighted. I want the inner white circle, so I move until I have that and then let go. And then my time step here, how long I've been going that fast. And now it's not enough to change my X position. I have to say go there to the apple. So go back to variables, X, Y. So we see X:X here and Y:Y. That means set your X and Y positions equal to the values that we have chosen. So when we click on the flag now, I see the apple moves to the right at a constant speed, must be no force in the horizontal direction, and all that remains to get our projectile motion is to repeat this process in the y direction, except we need some acceleration. So we want to add a line here that says change y by some amount. The amount we change y involves some acceleration, so I know I'm going to need two terms here. We've seen that before. Each of those is a product, and notice I can put green operators inside each other. I'm making sure I have that inner white circle highlighted. I let go. I can do the same thing in the second circle. So it's reasonable this should be the same quantity here for Vy. Instead of Vx times dt, I want to have Vy times dt. So what do you think will happen now? We have velocity 30 to the right and 40 up. Where is that apple going to end up? Let's see. That doesn't look quite right, not natural. So what you need to do is add something here that will give us the expected behavior. So this is the template we'll be working from, and you only need to make very small changes and you'll be able to report how far the apple goes and a few other things about the flight as well.